Hello, I'm George Gonzalez, and I'm obsessed with making games. And today is Multiplayer Monday. We are going to talk about the co op experience, PvE, and figuring out how that is different and how that affects your code. So, this is for developers that are trying to figure out multiplayer games. And this is just one aspect. Other we will in the future talk about PvP. We have PvP, we have PvE events, and within PvE, there's different types because there's times where you could do leaderboards. Even in a single player game, you can have leaderboards, guilds, and whatnot, alliances, and have those numbers just be stats that players work towards. But this is more in game. Okay, so my game, Magic Hunters, is about players that are trying to level up and improve, kind of like a Diablo RPG type, but simpler with gesture spells. So you use gestures to play the game, and you can play solo, single player the whole time, even though it's multiplayer. You can have a party code. We did that last time, and so now you can decide to go alone or with other people. Because of that, the experience can vary, and that's where code has to be thought about. I have to think about where I'm going to do certain things, and that's what I want to talk to you today. And this is very applicable because you will have a lot of, if you don't think about this at the beginning or throughout as you're coding, you will run into unwanted outcomes and you'll run into dead ends that you might not want. And so let's talk about these things. So if you're building a multiplayer game, first you have to determine if it's PvP or PvE. Even within PvP, there's certain other things, but we won't talk about that today. So let's focus on PvE, specifically co-op. You have to think about matchmaking. And we did a little bit of matchmaking in the previous video, and we'll link that below. I'll link it somewhere up here in the so you could see that. So matchmaking. The first thing is, how are players gonna find each other if they want to, or how are they gonna get matched even if they're not together? And I want to give you an example. So there's two. Last time we did party code, so you can do code to party up. You could do a list of rooms that are created so that people can join them, but that involves more clicking and typing. So if you don't have, if it's not VR, usually having rooms displayed is not that hard because people can type really fast. Or even in mobile, you just put in the name and hit save, and you can have some pre setups so people don't have to type much. In VR, it's a little bit harder because you have to type, and that adds dev cost and also friction. So I prefer to just seamless matchmaking. The other thing in VR is what's been happening now with free-to-play titles is screaming kids. Because in VR, you can't really do multiplayer games without voice chat. It's just weird, right? If you're all muted and you can't see each other, maybe that's something that you decide to do for your game. So when we do voice chat, you have a lot of screaming kids when free-to-play titles. So one thing that I'm going to do for my game is I'm going to have an opt-in version where people can opt in for either adult or more older audience. So if you want to be matched with older people or older audience, you can do that. And if there's a lot of screaming kids that end up being in your lobby, you can basically kick them out and have them banned from the older or adult rooms. And if you do that, what I can do is if someone was wrongly accused of being a kid or a screaming kid, they can go to Discord and fight that. Or, so we could do voice chat and see if they're actually kids or not, or probably just have them somehow prove that they're not kids. Okay. So that's something that we can do really easy. They can contest it because usually if someone's old enough, first old enough to be on Discord and old enough to prove it like on a voice chat, you can tell if someone's a kid or not. And so those are ways that we could figure out. So those are the things that I'm going to try to do to implement to avoid the screaming kid problem. A lot of people don't like that. And so we'll see how that goes, but we could do that with matchmaking. The second thing that all these things you want to think about early on because that determines how you structure your game, especially the code. And we went over the code for matchmaking last time. Saving progress. Okay, so let's talk about saving progress. So this is very big because you're in a single player game. If especially with this game, it's an RPG where you will constantly be progressing through a dungeon. And if you have, for example, on the Switch, you have games like you have the Kirby free-to-play game. There's a Kirby, I forgot what it was, but you go around and hit, and it's very like party Mario type game where you just play a session and you matchmake with others and you play that boss. And so most of your stats and stuff still remains intact. So the progress is not saved across. But if you're doing something like Diablo or any other type of game where you have multiple people going through a quest, and this happened a lot in Diablo 2, right? Because if you have, let's say you have to unlock you can't progress farther than your single player progress. Or sometimes you just have, and I'm thinking Diablo 2 because I played Diablo 3 and 4, but I didn't like it much because they reset the progress and other things every month or every season, and it was really annoying. But what I liked about Diablo 2, for example, I think, is that if you didn't have the spawn portals, you couldn't go to Act 3 or whatever. And the other things is that you progressed within the game. So I'm trying to remember exactly how it was, but I remember being able to accomplish a lot when I was in multiplayer games because people went through fast and we were able to get through like all the acts super fast, right? And so that helped me progress through the game. But I was also able to do it single player. And so there was different things that you could do in multiplayer. You could run through things faster and kind of grind for the specific things that drop the loot. So that was really nice. So progress was a lot faster, and if you wanted to kind of go through the experience and this lore, you go single player. And multiplayer was mainly for grinding. But in my game, what I want to do is I want to make sure that I have to think people are going to be jumping in and out constantly. I don't want to queue for matchmaking. And so my matchmaking is that players will come in and out. And so you'll be playing whenever you're playing. And you jump in and you see a bunch of people, you jump into the next scene. If you want to party up, you can party up with people there, or you can just go. And you just go to the next scene and whoever's there is there. But let me show you with a game, for example. I have this scene. It's called 0-1. And so what happens is when you start the game, I have these scenes and you have the central room. So this region 0. So we have the central room that has 3 portals, 0-1, 0-2, and 0-3. And so the idea with these is, and I'll just do that because I like to see them here. The idea with these is that each one has its own exploration area. So you have the spawn room, you have the first puzzle, the exploration area, and the dungeon. So you'll see we have the spawn area, which I'm testing and I need to improve, probably give more room for people to jump in and fight because it's a little bit crowded in here. And then you have what you call the puzzle, the first puzzle. And then from here, after this one, you have this big room where you're trying to figure out how to finish the room, and there's traps set around for enemies. Okay, so then once you clear this room, there's this dungeon, and this is what players will grind to get certain things. And in this first area, there'll be tech web tree to improve on the spell that you get, the fire spell. So each one of these areas will have a spell and a tech web tree for that spell, and you'll grind in this area. And right now this is like a horde mode with like 10 waves, and after that they drop, or maybe every wave. We'll see. At the end of it, when you finish the waves, you'll be able to get the reward, and then you use that reward to upgrade your tech web tree for your spell how you want. And so that's what I'm working on right now. And the way I'm thinking, the thing is that what I don't want happening is if players are here working through this horde mode, I don't want someone to jump in here and go through all these and it already be unlocked. So for example, this unlock is personal progress. If you have not unlocked this, it will not be unlocked. Now, if you spawn in this room and you fight off the enemies with other players, it will unlock the progress with you. Okay, so but the thing is that you have to kill the monsters that are needed to go through. So for example, and so that's something I have to take into account. At what point do we close off the room in here? Right, because we don't want players to keep coming in if this dungeon was already beaten. Because the moment this dungeon is beaten, the rewards are done. And also we don't want people to be fighting here and some people just waiting here for the loot and then just grab it all from other people. So we want it to be a positive experience. So how do I do that? Where should I stop progress, or where should I close down the room? Because that is the main takeaway from this that I have to do. Is not I have the scene progress, right? So in here I have the 3 walls and doors that I have that will be unlocked as you progress. I still have to add animations and other things, but right now the mechanic is as you progress through, it unlocks certain doors and it saves the progress. So that way you can continue moving forward. And so in this scenario, if you unlock this door, it will not spawn the monsters and you can continue. In this, if you've already cleared the puzzle, it will be already lit and you can go through. If you did this, it'll also be unlocked. And so the idea is that if you unlocked all 3, you can just go through and go straight to the dungeon to clear the dungeon. And the idea with the dungeon, you still have these traps here that I might do something about it so you know where the traps are. But you can use these traps to level up if you need to. But for the most part, you're going to be wanting to go here to grind the dungeon. And so that is available. And I'll try to figure something else so that people can figure, whether to, we'll see based on player feedback. But that's the idea. And so let's go back to the list. So I have the list, saving progress. Okay, so I talked about, okay, how do I save progress? And I'll show you. I want to make sure that you understand, okay, how does this apply with code, right? We have the concept, the game design aspect. How do we interpret this into also mechanics or in code? So what I created is I created this, what is called Scene Progress Manager. And so this is specifically doesn't have to do anything with multiplayer mechanics, but I will show you how this then translates, because if it was single player game, it's easy. You just do the same thing, but I don't have to worry about it. You do this, you get X, you get Y. But I'll show you how it differentiates with code. So in here we get the active scene because we have this progress data and it has a list and it's based on scene index. So scene 3, 4, 5, 6, whatever. They each have, I think right now, 10 different things that we can save. And if I don't use them, it's okay. But for the most part, we have 10. And if I need more, I can increase that. But for right now, we have a list of 10 items within depending on how many scenes we have. And so if I go in here and I'll show you, the product is 10 by 10. So we have 10 scenes, and I don't have 10 scenes I can show you in here. We only have 5. And only these 4 are the ones that we really care about. These are just in case I need to save something ahead of time and we could use it if we need to. But for now, this is all there is, and that's it. Okay, so we have 10 per scene that we get 10 items or things that we can save, or 3 events. 10. And so in here, even though we have 10, I have 3 that I'm looking for. So I have index 0, 1, and 2, and those things will be deactivated or activated depending on what the status is. So let me show you again, now that we know. See, if the current progress is 0, I say 0 because I save an int, their int, list of ints. And if the progress is unlocked, it is 2. I left 1 because at one point, I think in one of the other methods or something, I needed not just unlock and locked, but existed versus not existed. And then if it existed, I needed it to know if it was unlocked. But I ended up just doing this because they all exist now. And I still keep the 1 just in case I need an extra feature, right? An extra check in between to say maybe it's unlocked, but the progress was never finished or something, if that is needed. Or you unlocked part of it and we need to save part of it, or this or that. We could use it for something in between if we need it. But for the most part, it's 0 or 2. And then, okay, so now is the multiplayer aspect. Oftentimes you have items that are non-multiplayer, so that's okay. But when it comes to, for example, let's say the spawn. So what I wanted to do is say, okay, when you beat up 2 monsters, you can unlock the door. Like this thing, let me see, I'll show you here. We have objective spawn. Okay, I had to make a multiplayer object, a network object, and I have to make sure is master client is checked, I believe, because we want it to be. Okay, so let's see what we have. So if this will happen on everybody, regardless. But we do want someone to have state authority if it changes. So we do want it to be the master client, because that way, if the master client leaves, it doesn't get destroyed. Okay, because if the master client leaves and this gets destroyed, the next person that comes in after the master client leaves is not going to have this, and they're going to get stuck again. So you got to understand what's going on, what's happening, and because we don't have a check on this, here's what happens. I don't check if you have state authority, because the idea with this, and I'm going to zoom in the code. I can zoom in now. The idea with this is that we have the local player, that this is going to happen and get called on everybody, regardless of who you are. And so we say, okay, whoever's the local player, that's the ID. And the reason why I do this is because we have to spawn enemies and give them a specific ID, event index. Okay? And the reason we do this, I'll show you, spawn enemies, and here. We have a spawn event with an event index. And if I go into, we needed to find a way to say, okay, when this enemy dies, I need to know who it's for, okay? Because everyone's gonna get this call, okay? Because you gotta remember, this is networked. Everyone has one of these. So let me show you in the picture. And this is why I wanted to talk about this, really focusing on this, because it's really hard to grasp the concept. Let me see if I can change color. Let's do green. Okay, so we have, let's say, a monster. Okay, and let's say the enemy is red or something red. Okay, so we have enemies that spawns because of this guy. So this guy spawns 2 enemies, and this has to do with like the experience, the player experience, as you see in here. Okay, in single player, we have the player. So player, enemy, enemy, and what happens is we have another. Let's do blue for the door or unlock, whatever you're trying to lock, right? So the idea is when these enemies die, I'll say they die, they're dead, this unlocks. Okay, single player, easy. Okay, but now how do we do that in co-op, right? Because people are going to be coming in. You have there, if you did matchmaking where you, what is it called, lobby up, or you have a lobby and you party up and then you go to the scene, it's a lot easier to do these things. That's why you think about this early on, because then you say, oh well, this experience is easy, like Minecraft dungeons. You choose how many people are going to play, and then you go. You can't have people join halfway through because the dungeon's already created. You're all together. The progress is saved together. Okay, so that's a lot easier because you spawn 4 enemies, and those are the 4 enemies that exist. So technically, in the scenario where you lobby up, you can have 2 players come in and they have to defeat 2 enemies. 3 players come in, they have to defeat 2 enemies. But what I want to do is, because some players, let's say players are going to come in one at a time, right? So they're coming in, spawns 2 enemies. This guy defeats the enemies and goes through the door, and then he's in the next dungeon, in the next puzzle. So think of Zelda, right? Imagine if people are going through a dungeon and you're running into people, right? So the idea, the experience I want is for players to be like, hey, what's up? Like, you're coming along, you're just walking along this dungeon. Oh, hey, you're here too. Let's play together or whatever. Like, so you're passing by and you have your solo experience, but your solo experience is happening asynchronous from the other player. So, but you're together in the same space, just like in the real world. And you would say it's like an MMO RPG, but I'm not doing the massive part, right? It's just 4 or 5 players, so people are coming in and out. So it'll feel like an MMO, but it's not. And so one other player comes. Do I want this to already be done, right? And so then the player's like, oh, I don't have to do anything. I just go through. That's not the idea. And so what I have is every time someone comes in, it's going to spawn 2 enemies. So if 2 players come in almost at the same time, regardless of when they come in, there'll be 2 enemies. So for every player, there'll be 2 enemies. And so if 2 players show up, they'll see 4 enemies. The doors, so this is, let's say this is player 1 and this is player 2. So what I did, this is why I have the local ID, is because then this is enemy 2, enemy 2, enemy 1. So what will happen, I'm trying to explain. So every enemy has an index now of who spawned it. If these 2 guys fight these enemies and they die, the door will open. There's also, the door is single player, but because I don't have any network mechanisms, I have to make sure it opens. So this door will only open for player 1. And so if he wants to run and leave him alone with these 2, he can. They don't know which one's which is something that I can get feedback from and see, okay, is this something players want? Do players prefer something else? And then these guys, when they get beaten, they go together. Ideally, these 2 guys are going to try to kill all the enemies in the room, okay? Regardless of who they are. So hopefully they'll fight all these. Now the rooms have up to 8 players. So if you can imagine 8 players coming in and then you have 16 enemies from the get-go, that's kind of crazy, right? But yeah, so that's how I scale it. Other games scale multiplayer games by HP, so they make the enemy harder and tankier. But we'll see how it scales, and we can change that. It's just code, right? But the idea is tying the enemy to the player and the objective to the player. So that way you still have that single player mechanism working, and it's just layered on top. And it works the same for multiplayer games. That is the idea. And I know it's a lot to think about because it's like, how do I, and then it's multiplayer. So I have to make sure that when this spawns, even if this guy kills him, this enemy, every time it dies, it tells everyone that it died. So this guy will get a notification, this guy will get a notification, and if these 2 match the numbers, then they will open up the door for that player, if that makes sense. So even though everyone's getting, that's the other thing that you have to think about is everyone, let me show you, this script, spawn with objective, is going to get this listener that says enemy killed has an int. This is going to get called on everything. So the enemy dies, boom, it goes out to everybody. So instead of me trying to filter who it goes to, which I could do, I check here. That's where I check. So I spawn it, right? I spawn the event with the index. And then when it comes back, I check that same index. And so that's the first thing I have to do. And then you have enemy count and how many, let me see, spawn enemies. Enemy counts as the max enemies. So I spawn 2 enemies, I delete 2 enemies. 1, 2, yeah. So it should be good. And then let's go into the enemies, because then we have this event, right? So we have in here the events. So when you spawn event, it will spawn here, event spawner. And we've seen this before in previous monsters. We have this RPC spawn. So this spawns the enemy on, so anyone can make this call and say spawn enemies, and the master client will spawn the enemies. Now we have this RPC, the same thing, but this time with an event index. And the reason I call this event index and not player index is because this can be anything, right? I can reuse this event where like, oh, this enemy needs to die before this thing happens. We can still do that without having to have the player index, right? It's an event index because we are trying to spawn an enemy that requires a certain, like you could say, code that we're looking for. So this is when we want to kind of like tag the enemy with something, with a number. And so this is, you could say tag index or something, or tag ID. Maybe that's a better word for it. And then we spawn it, and in here we set up the enemy, and now we have event index. And what happens in here is the event index is 0 by default. So that way we can still spawn like we used to. It just spawns 0. And 0 is not, oh yeah, 0 is, an event. So see, so there, now we found something. The idea, since this is an int, I would do -1. Because -1 is not gonna affect this guy. Because these guys will still spawn, everyone will have a tag and everyone will register that event. And so I just caught an error that could have happened. So the first player could probably get default. And the reason why I do this is because now you have to think about players. Oh man, it's gonna take a while. So players that are in here fighting these monsters will trigger the event that the monster was killed regardless. And so I want a default value that I'm not gonna get from the player. So 0 is a player ID, then it's 0, 1, 2, 3, 4, and so on. So if I do -1, it will never happen. We have in here on before spawn. So the way, if you weren't paying attention, in here, the runner, this is Fusion specific, but I know Unity does it. In Geo, they have a certain same thing where you can have a call before the spawn mechanic, so you can kind of set up the enemy. So this enemy base class. So I have this network object that's about to spawn, and I can do this on the master. And this is happening on the master client before it spawns. So these are, if you look at network int, I'm filling out these variables just to make sure that they're set to certain things. And these are incoming values. And if there's nothing here, what I need to do is -1, like we said before. The ID should be -1, so it doesn't count for a 0. This equals allows it, what it does is sets it by default. So that way, if I go to one of these, like this horde mode, see how it doesn't have the ID? I could have an ID in there, but I don't need to. So that way, if you add a mechanic and you don't want to change all 7 spots, you can just have a default value, because usually those other mechanics work without it. And so this is a nice way to set the default value. And if you want to set it for that one use case where we have it, we can do that. So I can go back in here and in the enemy spawner, the event enemy. So in here where I have the event index, I could just not have this and do that. So I could just remove this and not have anything and not even use this. So I can do that, and that will be fine because this event doesn't use it. And so then the only place that right now I have it is this enemy's the event. Hold on, the enemy spawner. Oh, I keep grabbing the wrong one because I keep forgetting. But event spawner. So this event spawner will give me the specific one, and then this one up here on before spawn. In here we usually have the event index, the default event index. So we set it here. So that's why we have that. So that is the setup. So the enemy has in here objective index, and up here is the network ID. And then this index, if we do Control F for this index, we can see what is being used for. So in here, so when the enemy is destroyed, so this is happening on everybody. Again, like I said, everyone's going to receive the event. So if there's anyone listing for the objective, it will grab the index and it will understand that that's what's going on. So this is not going to, and then we have others like on enemy killed, tell everyone that the enemy was killed. So if you don't, this is specifically for when you have an objective where you need to know that that enemy was killed. And so that's what this does. And that is pretty much it. And as long as, like I said, this is a public network variable, that means that when the master client sets it, it's there for everybody. And because we do it before spawn, it's guaranteed to be that number when it's spawned for everybody, regardless of when the other people are coming in. Okay, so we don't have to do any crazy shenanigans with this, because a lot of problems arise from the use of these network objects. And so that's why I wanted to show you guys this, so that you see the full picture. And you have, if you wanted to follow this, you can follow the logic and the setup for Fusion. And it's a similar thing with Unity and other network solutions. Because oftentimes you're going to go crazy because not only do you have that you don't know when this is going to happen for everybody, the master client will always happen first, but there's no way for you to like guarantee that number is going to be at the same, like the logic, the timing is impossible to create a system where you're like, okay, this is going to run first, this is second, because there's so many things that happen. And when you have the start function and the awake function, even in single player, there's a lot of complexity that happens because you don't know what happened first, and you're always like chasing things because you're like, okay, this has to happen first, then this, then that, and so then you do these delays or these weird things, and you can create things that make the class run a certain order. So as a single player, you can fix that. But oftentimes, if you have things that are dependent on each other, you are running into a lot of problems. And so this is a good way to set up a spawned object without having to worry about anything else. It's like the moment this thing spawns, those variables are going to be set for everybody the same, and you don't have to worry about it. You don't have to do anything crazy like wait for this, wait for that, and back and forth. Okay, when I spawn it, I say spawn this specific thing with these parameters. And it's so much nicer. Like it makes life so much easier. So instead of you trying to reinvent the wheel, just a networked int and done. Okay, the other thing I have in here is this portal that will take you back if you want to go back. And we have in the process of fixing that art. But that is the general idea with these co-op modes, is thinking about like unlock mechanisms, saving progress, and then testing, like how you join the room. And so I'm going to set up a way to, when do I lock this? I think in here, see, it says lock room. So the moment you turn on this portal that you're done, this room is locked. Now everybody that's in here can wait for everybody and say, hey, is everybody ready to go to the dungeon? Or they can just leave if they want to. And this dungeon doesn't scale based on amount of players. So it's not like this one. What happens is this just spawns monsters. And so the level cap is set regardless of how many players. So if you go in with 8 players, this is a good thing because there's no scale. And so it encourages people to come in and co-op. But if you want to try to beat it alone, you can. I could do rewards for solo players, but for the most part, I want to encourage people to come in together, and I want them to have benefits for coming together. So that way, kind of like that Diablo experience, that when you come with co-op, you can just blast through this and do it multiple times. And so then you'll just try to do, how do we do the fastest, how do we do this dungeon faster and faster every time? And that's where this is where I have to take my own feedback that I just talked to you about, which is it's important to think about, because I don't know everything, but you can anticipate certain things. So what can I anticipate? Well, I now that I've talked about it, I talked through the game loop. People are going to try to find the most optimal way to run through these dungeons as fast as possible. And so what is that going to look like? So people are going to try to do 8 players, right? And so they're going to start this room, and this is going to load up. And so this room has to give you more room, more space to play in. This room is fine. Like most of these rooms will be unlocked, remember? So people are going to optimize it. What they're going to do is they're going to say, okay, we need 8 players that have already gone through the place, and this is the party code. They're going to have a party code, and they're going to go through. And then in here, they're just going to go through everything. Everything's going to be locked, and they're just going to run through, and they're going to try to avoid these traps. They're going to learn where the traps are, and they're just going to run in the dungeon and clear as fast as possible. Everyone's going to like position themselves. They're going to get it done, and then they're going to teleport back, and then they're going to go back and forth, rinse and repeat, doing that with the party code. And so I have to test that mechanic to see if everything works accordingly for that experience, because eventually people are going to get to that optimal room. And there might be bugs. There's things that are like, is the party code going to work? Because the moment this thing gets, for example, now that I said that, the moment this gets turned on, which is probably saved, right? So this will lock the room. The problem is if you don't unlock this, this progress is not saved. The door is saved, but the room is not. So players will come in and they can fight this monster, but the room is not going to be locked while they're doing the dungeon, which is okay if they all leave. If they don't leave, someone could come in and everything's empty. So I have to make sure that I also, for example, maybe when this dungeon is finished, like when they finish that dungeon, that the room is closed completely. And so that's something I can work on, that I'll put on the list right now. Lock room completely. Completely after dungeon is cleared. And so running through these scenarios in your head, like I just did, is helpful because it gives you those edge cases. And obviously you can't think of everything, but even if I didn't know what was going to happen, I could write a note about, think of this, think of that, and then test it out and go through it and run the experience and see how it happens. And that will help you test things in the right scenario, because again, until you launch, you won't know what happens. And I'm telling you this now because even when I know things, I know that there's things that I'm never going to be able to capture or think about. That's why, like, even after testing, you won't find. And then when you release a game and thousands of people play it, they'll find bugs and patches still, and things and exploits, and that's okay. So you just have to be aware that that's going to happen and anticipate certain things that you're going to spend time learning from those experiences. Hopefully this helps. If you have any comments or any questions, if you have multiplayer mechanics, games, or things that you're stuck on or that you want me to talk about, let's talk about it. Leave a comment below. Have you ever made a multiplayer game? Have you ever wanted to, but were afraid to know how to start? What is stopping you from making a multiplayer game? Comment below and we can talk about it next week. We'll see you on the next video.